Yep. Okay. So anytime we develop some functionality, we have to write our test cases and we have to make sure the test or the function is working as expected. So we will look at what are the different ways that you can test your application. Yeah, so let me start off with opening PyCharm here. So in the previous session, we were looking at classes, right? How do you declare a class? What is the initialization method? What are the different member methods, functions that are inside the class, how to call that class, and so on. So we're going to extend that concept in this unit test feature. And I'm going to show you Python has a nice unit testing feature that we can use. So I'm going to open up a new hopefully you guys can see this, right? Or should I change the background, foreground colors?
Yeah, font size is so small. Even though I see it in a big screen, it's not visible.
Okay, no, that's not good either.
Mhm.
I think this is the best I could do. Import unit test. Can you guys see the top here? It says import unit test here.
Yes, yes.
Okay. All right. I'm increasing a little bit more. Okay. All right. So so in Python, anytime you want to import certain modules, or Python has a lot of inbuilt functionality. And if I want to get some of the functionality, I have to use this import statement. And here I'm importing something called as a unit test. And what does it give me? We're going to look at a few things here. Okay. So first, let me write a function called add, which adds two numbers. Okay. So let's say I have add, which takes A and B. Okay. And let's say it returns A plus B. Okay. So that's all it does. So here the return statement means that is the return value from the function. Okay. So now if I do print add of 2 and 3, and as you guys can guess, I'm adding 2 and 3. So the return value is 2 plus 3, which is 5. So this print should print 5. Okay. So let me just run this. And as expected, at the bottom, you can see it prints 5. Okay. So at the bottom, I hope you guys can see it prints 5. Okay. That's because the function is pretty much adding two numbers, and we get the return value. Okay. Now, how do let's say I'm just demoing a simple example, but this can apply for any complex function that can do any complex functionality and so on. But now let's say somebody has written a function and they ask you to test it. Okay, so you are supposed to write a test case to make sure that this is working as expected. How do we do that? Okay, so they tell you that, hey, I have an addition function. Can you write some test cases to make sure that it is working as expected? Okay, so now let's say we are working as a tester and we have to make sure that this code is working. Okay, so what I'm going to do is I'm going to write something like a class which says test add. Okay, and this class is not a simple addition or a test class. I need to say that this is a test class. Okay, I mean I can name it anything I want, but if I say this unit test dot test case, now this becomes, so as long as I say as long as I put the parentheses, and inside the parentheses I say unit test.test case. That means this becomes a base class and this becomes a derived class. Okay, so all the functionality of this base class are derived in the derived class. Okay, so this is what we are looking at in the previous session. You have a base class, you have a derived class, and all the functionality of the base class you're going to get into the derived class. Okay, so here test add is a derived class, and this is a base class, and all the functionality of this test case or whatever it is, we are getting it for free here. Okay, now I'm going to write a simple test case. Okay, so I'm going to say test underscore simple. Okay, so anything that starts with test underscore becomes a test case. Okay, so by default, if it has the keyword test as a beginning 4 characters, that is a test case. Okay, so so I'm writing a simple test case here. Okay, so what I'm going to do here is I'm going to say self dot assert equal. Now what this assert equal does, yeah, I'm going to demo it in a second, but let's say that if I add 2 and 3, I know that the return value should be 5. Okay, so I'm going to say add 2 and 3, and I'm expecting the value to be 5. Okay, that means it's going to call this function, which is add 2 and 3, and that function is going to give me back value 5. Okay, now this function, the assert equal, what it does is it will compare these 2 parameters. That means this value, which is the function value, and the 5 value. As long as they match, that means the test case succeeds. If it doesn't match, then it will be a failure. Okay, so let me run this for a second. Okay, yeah, I have to put another piece of code here, so I'm going to remove this, and I'm going to say unit test dot main. Okay. All right, so at the bottom, you can see that what happened here is forget about this statement, which is unit test dot main statement. I'm going to come back and talk about that in a minute. But yeah, pretty much here what we did is we said test underscore simple. That means that becomes a test case. And I'm saying that call this function, which is adding 2 numbers, and that gives me back value 5. So since I know what is the input, I also know what is the output also here. Okay. So, and then I have the return value 5. So I'm comparing this 5 with that 5, and that's it. So it says here at the bottom, you can see that it says ran 1 test, and the result is okay. Okay means the test case succeeded. Okay. Now let's say somebody comes along and modifies this function, return a plus b. Let's say they have a bug in the sense it's not working as expected. Okay, so now they, instead of returning just a and b, the sum of a and b, they return some incorrect value. Okay, so let's say there's a bug in there and they return incorrect value. Now let's say if I run this code now, and you can see at the bottom, it throws an error. It says failed with it says failures equal to 1. Okay, that means that the test case has failed, and let's look at the reason. Okay, so what it did is it ran the test case, and it's expecting a value of 5 in the test case, but we actually got 4. Okay, and if you look at the error message here at the bottom, it shows that assertion error 4 not equal to 5. Okay, now you know exactly where the value 4 came from and where is the value 5. Okay, the 4 came from the function that we call the function, and we are expecting the value to be 5. Okay, so this is a simple test case. Okay, that means if I add 2 numbers, I should get back 5. If I add 2 and 3, but I got back 4, that means that means the test case has failed. Okay, so the framework here provides nice statistics, like saying we ran 1 test and how many failed, how many succeeded, and all that. Okay. Now let's add another test case here. Okay. Complex. Okay. And here complex will be maybe assert equal and 1000 and 2000. Okay. So if I add those 1,000 and 2,000, I should get back 3,000, right? And let's add something else, test 0. Okay. If I add 0, I should get back a 0. Okay. Let's also test negative numbers. Okay. So let's also test some negative numbers. So now, can you just guess how many test cases do I have here? Yeah, any one of you can unmute and tell it to me.
4.
Yeah, 4. That's correct. Because I have 4 functions here, which start with test underscore. So anytime any function that starts with test underscore, that becomes a test case. Okay. So I have 4 functions here with different use cases. Okay. So one is a simple use case. I have something like if I add 2 numbers, I should get back the expected value. Okay. Now I called it complex, but it's not really that complex. The second test case, I'm adding 1,000 and 2,000. This is just for demonstration purpose, but it can be, you get the idea that I'm passing really large numbers and I'm expecting the return value of 3,000. Okay. And then I have another test case, which is adding zero values. So we are trying to test different input, and we are trying to get the output that we expect. Okay, if it doesn't give me the expected output, that means the function is not working as expected. Okay, so I'm going to run this test case, and as Smita said, so there should be 4 test cases that should run here. Let me fix the function first. Okay, so at the bottom you could see that it says ran 4 tests. And they're all okay. Okay means they all succeeded. Okay. So here you can see that Python actually figured out there are 4 tests, and it also figured out they all ran successfully because now it knows exactly what is the expected values and does it match or not match. Okay. If it doesn't match, then pretty much it throws an error. Okay. So let's also do this, right? Just maybe. Yeah, that's fine. So here, when I'm adding 2 negative numbers, I should get back a value less than 0. Okay, so I can also do this. Assert less equals. Okay, assert less is fine. And minus 2 minus 5 should be less than 0. Okay, so this there's a function. So there are different type of asserts. Okay, so what we saw so far is assert equal. But you also have assert less than, assert greater than. And assert pretty much means that if it doesn't match with what I'm expecting, then that's a failure. Okay. So it's a very hard failure. There is also soft failures that we can look at later, but this is a hard failure. That means if it doesn't match, that's it. The test case has failed. It will move on to the next test case. Okay. So let's say this failed, then it will go to the next case. Okay. In the sense, if I have like different statements here, let's say I have this self dot assert less add 200 and 0 should be greater than 100. Okay, so I'm going to say assert greater. Okay, so here I'm saying if I add 200 and 100, 200 and 0, that should be greater than 100. Okay, so that is what assert greater means. Assert greater means I'm expecting the first value to be greater than the second value. Okay. So let's say that this first condition failed. Okay, the assert of the first condition, and that will pretty much stop the execution of the test case, and it will move to the next test case. It won't even execute line number 13, this line. It will just move on to the next test case because the first one failed. It will just mark the test case as failure. It will move on to the next test case. Okay. All right. So if I run this right now. So you're still going to see that it ran 4 tests and everything is okay. Okay. So this is something nice statistics that Python's inbuilt unit test provides. And I just demonstrated a very simple use case, but this function can be very complex. I mean, here I just have an add function, but you can have something like going to a web page, getting some elements, placing an order. It can be placing an order and then going to the database to verify the order is really placed, or it can be very complex in the sense you can make a transaction like a banking transaction or something, and then you check the account balance, whether the account balance has gone down, up, or depending on what kind of transaction you made. So all those kind of complex test cases, you can test it. Okay. But that function is pretty much a separate function that we are writing the test cases for. Okay. So this function is something somebody else will write, or maybe you are writing that test, you are writing that functionality. Okay. But these test cases will be in a separate file. It won't be in the same file. The test cases will always be in a separate test file, and we will be testing the functionality from a different module. Okay. Here, for simplicity, I put it in the same file, but it's usually in a separate file. Okay? All right. Now, coming to this statement, which is unit test.main. Okay. So, in Python, what happens is since I imported that unit test module, when I say unit test.main, what it will do is it will look for all classes that are derived from the test case. Okay, so it will look at all test cases and then it will start executing those test cases. Okay, so that's all the unit test.main does. So main will look for all classes that are derived from the test case, and it will start executing those tests. Okay. Yeah. Any questions so far?
So if any one test case fails, do we get explicit message about which
Yeah.
test case has failed?
Yeah. So here, let's say if I'm expecting 2000, okay, in this I just changed it. So if I add 1000 and 2000, but instead of 3000, I'm expecting 2000. Okay, I mean this is a hypothetical example. But
Yeah.
if I run this now, what happens is you can see that. So it says first we'll look at the statistics. It says ran 4 tests. Failed equal to 1. Okay, failures equal to 1. That means only 1 failed, 3 succeeded. Okay. Now let's look at the error message. Okay, it says assertion error. What is the assertion error? 3000 not equal to 2000. Okay, that means
Okay, it's clear.
yeah, exactly. So you are expecting 2000, but it got 3000. Okay. It also tells you the line number, all those details. Okay, so you can see here it says line number 12 in test underscore complex. It also gives you the statement. What is that value and why did it fail and all that. Okay, so it gives as much information as possible so that you can
Okay.
go back and see why it failed and all that. Okay. But yeah, it will explicitly. The funny thing is, it won't execute this line because the line that is above failed. It will not continue. Okay. So if I have a print statement here, print ABC, G or something, so that print statement will not be printed. This, so you can see that print ABCD won't be printed here.
Yeah.
Yeah. Okay. All right. All right. So that. Yeah, so here, these are all the test cases, right? Now, let's say if I have a function that doesn't have the keyword test underscore, okay? So if I say something like dummy, okay, dummy function, okay? Dummy function doesn't do anything, so I'm just going to put pass statement there, or maybe print statement. Okay? Print. Now, so this doesn't have the keyword something like test underscore with the beginning of the function. Okay, so now that is not a test case. Okay, so if I run this, So that will show me that there are only 4 tests, not 5 tests. Okay, let me run this, and you can see that it says only 4 tests because that dummy underscore function doesn't start with the name test underscore. Okay, since it didn't start with test underscore, that is not a test case, and it will not execute that function. Okay. Now you might be thinking, why do I need this dummy function? So if you want to have a helper function, you can call those helper functions from the actual test cases. Okay, just in case if you want to put some common code, let's say I have something common between these 3 functions. Okay, so any common code between those functions, I can put it in a separate function, and I can call that function if I want to. But yeah, so since that dummy function doesn't start with test underscore, that's not a test function. Okay. Okay, so now there's another special method called as setup. Okay, so let's say, okay, all right. Now the setup is a special method. What it does is it will call the setup only once, and then it will call the test cases. Okay, so if I print this is setup. Okay, so this setup method will be called for each test case. Okay, so every time this test case is run, each of those test cases, it will call the setup, and then it will run the test case. And for this test underscore complex, it will call the setup, and then it will execute the test complex. Okay, so it will first set up that call the setup function, and then it will call the test case. And this is completely optional. You don't need to have that function there. If you have it, then it will call that. If you don't have it, it won't call it. Okay. You might be thinking, why do I need a setup? Okay, so let's say you want to load a web page or log in a user. Okay, a user has to be logged in, and then you want to run some test case. Okay, so that setup where you are opening a web page, you're logging into a web page, all that is a setup part. So you are actually doing that in the setup phase, and then you are actually running these test cases. Okay, so all that kind of common code you can put in the setup. Okay. Now, since I have 4 test cases here, this setup will be called 4 times, and that should print 4 times. Okay, so let's run this. Okay, so you can see that it prints. Yeah, this is setup, and here is a second time it prints. This is setup. Yeah, so it prints multiple times. Pretty much it should print 4 times. 1, 2, 3. I see 4 times. Okay, since there are 4 test cases, it will call the setup 4 times. Okay. So if I want to open up a database connection, I can put inside the setup. Okay, all that will be going to the setup. Okay, you can open a database connection or a web page, any common code that you want. For the first time, you can put in the setup. Now let's say you open up a database connection, you ran a test case. Now you want to close the connection, right? So there's something else called teardown. Okay. Now the teardown is very similar to setup. Okay. So the teardown is very similar to setup, that it will be called only once, but after the test case is run. Okay. Setup is called before the test case is run, and teardown is called after the test case is run. Okay. So now if I run this, you should see this is setup, and then you should see this is teardown 4 times. Okay. Okay. So you can see that it says this is setup and this is teardown. Okay. And then again, this is setup, this is teardown, this is setup, this is teardown again. So you can see the order. Okay, first it calls the setup, and then it calls teardown, and so on. Okay, and now you might be thinking, why is this run 4 tests is in between that setup and teardown? Okay, so there's a reason why this happens this way, because that ran 4 tests is actually printing out to error stream, or in the sense there are different output modules available. One is a actual output, the other is error output, and all that. It's like a error output doesn't mean it's error actually, but it just is like a, I should say, kind of like a status or so on. So that can be printed. So PyCharm actually is what is trying to do. It's actually combining those two into a single window. Since the window is single, it's trying to combine, and that's why you see in between those statements. But yeah, don't worry about that. It's pretty much that it's printing that this is set up first, and then it's calling this is teardown. This is set up, this is teardown, and all that. Okay. All right. So now we saw setup class, setup function that is called for every test case. Okay. Now let's say if you want only to call setup only once for the whole class, for all the 10 functions, for all the 4 test cases, you want to call setup only once. Okay. There's another setup called as class setup. Okay. So let's setup class. Okay. Okay. So this class setup, what it pretty much means that this will be called only once for all the test cases. Okay. So let's say if you have some code um, that you want to run only once, you don't want to run for each test case. You want to open up a file and you want to put something in the file. Okay. So you want to open up the file only once and then maybe write to the file for all test cases. And then maybe you want to close the file and so on. Okay. So in those kind of common cases where you want to execute some piece of code only once for all the test cases, then you put in the setup class. Okay. Now this function, sorry, this statement will be printed only once. It won't be printed 4 times. Right. Setup class missing one required positional argument, CLS.
Self needs to be added.
So self makes it part of an instance. Then it will be pretty much becomes for every test case. This is a class level setup, so that should be CLS, which is a class. So let me do this actually. Let me try this. Yeah, okay. Wait, this is class setup. It's not even printing. Okay. Let me just check something. Okay, setup. Oh, I have to put the decorator. This at the rate class method. So let me.
Oh.
So what I was missing was that at the rate decorator on the top, which says it's a class method. And now if I run this, we should see that this is a class setup only once. Okay. So I just ran it, and you can see here it prints this is a class setup only once. And then you're going to see setup teardown, and all that. Okay.
Yes.
So anything that you want to do once for all the test cases, you put inside the setup class level setup. Okay. But if you want to do something for each test case, you would put it inside the self setup or instance level setup function. Okay. And similar, as you can guess, similar to setup and teardown, you also have a setup class and a teardown class at the class level. Okay. So I also have this, which is separate. Okay, so this is Teardown class, and this is executed only once. Okay, so if I run this, you should see this a class setup that is called first one. Okay, because yeah, so this is called first because it's a class level setup, and at the bottom of the window, hope you guys can see it. It says class level setup. Okay, and then it will call setup teardown of all these instances. Okay, and then at the bottom you can see this a teardown class, which is a teardown class method and all that. Okay. But yeah, so this is a very simple demonstration of a unit test. How do you write a unit test cases? What are the methods, setup? What does it mean when it starts with test underscore? When anything starting with test underscore becomes a test case automatically. And Python detects that it's a test case, and it will keep track of how many failed, how many succeeded. So there are different asserts. We saw assert equal, assert less than, assert greater, and there are other type of asserts. So let's see. So there is a assert true. Okay, assert false. So here assert true, I can say 1 equal to 1. Okay, that means so you can see that assert true 1 equal to 1. That means it's expecting the return value to be true. Okay, that means that 1 equals 1 will be a true value, and that will be fine. Okay. Now assert false is expecting that to be false. Okay, that means if it is false, that is fine, but if it is true, then the test case has failed. Okay. Yeah. So this ran fine. Everything is fine here. But yeah, there are different type of asserts. Okay, there's assert equal, less than, greater than, assert true, false. There are different asserts also. You also have assert almost equal. Okay, so let's say you are dividing 1 by 3. Okay, so there's also something called as assert almost equal. That pretty much means that you are trying to compare two numbers, but there is no way you can compare to the exact precision, because if you divide 1 by 3, you're going to get 0.333 and all that for like infinite numbers. Okay, but you're saying I don't want to, that will never be equal, right? I mean, I cannot compare with that. So now if I say assert almost equal, it pretty much takes two numbers and compares that they are closely equal to other one and all that. Okay, so there are different type of asserts. Depending on which what is the use case, we can use the appropriate one. Okay, so that yeah, I mean there are only two candidates here, so I'm gonna probably take questions right now, and probably I'm gonna end this session. Maybe I will continue with the next session. Maybe I should remind others, but yeah. Any questions so far?
So with this setup and tear down, we can get the database connection in the
Yes,
class level. If you want to test all the test cases, run all the test cases, then we can do the class level setup and tear down. That
yes,
will work, right?
exactly. So if you want to open up a
Okay.
database connection, you should set it up in that class level, and then in the test case, you can use the database connection, and then in the teardown, you can close that connection. That's correct. Yeah.